Hey guys, welcome. Yeah, so in a previous video, I showed you how to derive the equation of a circle. And in this video, we're going to see 3 examples that will be all the necessary examples. And by that, I mean, once you see these 3 examples, you will have seen all the different variety of questions one can ask on the equation of a circle. Now, the first variety is this, which is to give you the graph of a circle on the coordinate axes, and then to ask you for the equation of the circle. Okay, now from the video where we derived the equation of a circle, we know that the standard equation of a circle is this here, where h comma k is the center and r is the radius. So the first thing we need to do is go to our graph and figure out the center. And it's clear that the center here is 4 comma negative 3. Yeah, so h is 4 and k is negative 3. That's what we gather from that. And it's obvious that the radius is 2, and the easiest way to count the radius is to go from the center east to the border of the circle like this, or west, or north, or south. Although we can go in any direction, those are the easiest to count: east, west, north, or south. And it's obvious that the radius r here is 2. So we've got everything we need. So we substitute. And when we do notice that in this part, we have, since k is negative 3, we have y minus k. That's y minus a negative 3. So we're going to get y plus 3 once we simplify this here. And of course, we're going to write, instead of 2 squared, we're going to write a 4. And yeah, so that's that. And that's how you answer a question like this. Okay, cool. So the second variety is to give you the equation of a circle in standard form and to ask you for the center and radius. Now, this is a pretty straightforward task, but I just wanted to show you some nuances. So again, keep it simple and go back to the equation of the circle that we derived, which is like this. So whatever equation you're given in standard form, write it exactly in this form. So to write it in this form, this is what we'd have to do, which is we'd have to say, since there's no number next to this x here, that must mean that we have x minus 0. So h is 0. And then since we're supposed to have y minus k here, and we have instead y plus, it must mean that we had y minus a negative 1. And so k is negative 1. And then don't forget that the right hand side is supposed to be r squared. And so 3 is r squared, meaning r must be the square root of 3. Yeah? Okay, cool. So that takes care of you for all the different nuances that could accompany a question such as this one. Okay, the third and final variety is perhaps the most challenging, but it's not really difficult. This would be what the task would look like. So you're given what I'd like to call the scrambled equation of a circle, and then you're asked to find invariably the radius and the center. And I call this the scrambled equation of a circle because, well, look, like the x's and the y's are scrambled. And the task here is to take the scrambled equation and turn it into the standard equation. That way we can quickly tell the center and radius. And to do that, to change the scrambled equation to the standard equation, what we need to do is complete the square both on x and y. And of course, in order for us to accomplish that, we should get the x's together and the y's together. And you could move any constants that don't have an x or a y to the right hand side of the equal sign. So here, like negative 4 didn't have an x or a y, so I added 4 to both sides to take this constant to the right hand side. But it's permissible to leave the constant on the left hand side. It's not a big deal. But of course, very important is to get the x's together and the y's together. And then next, as a good habit, and just like how like moving the constants to the right hand side may be a good habit, as a good habit in the next step, what I do is I take the x terms and then write plus blank, knowing that I have to add a third term to these two x terms in order to turn this into a perfect square. And do similarly with the y's. And the same 2 blanks I have on the left, I have on the right. That way, I don't forget to do what I do to the left-hand side to the right-hand side. Yeah? Okay, cool. It's pretty clear that to complete the square on x squared plus 2x, what we need to do is add 1, right? And so I do that, but then since I have my blank on the right hand side to remind me, I don't forget to write +1 on the right hand side as well. Okay, cool. And then on the y's, what we need to do is add 4. So we do that both to the left side and the right side. And now we've got a perfect square here and a perfect square here and a nice number on the right. Now, I admit, and this perfect square, by the way, is x plus 1 all squared, and the y perfect square is y minus 2 all squared. And then, of course, the right-hand side, 9 is 3 squared. Now, I admit, as I was going to say, that like this completing the square was fairly straightforward. In other words, what you might have to deal with might be like fractions and more cumbersome algebra and more cumbersome arithmetic. But, you know, this is not a video on completing the square, so I wanted to make it this final example more about the process than actually, like, you know, the cumbersome algebra or arithmetic. Yeah, cool. All right. Otherwise, I hope you enjoyed this and keep watching. Take care.